friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve a very popular matrix related coding problem. It's quite recent on Leetcode. It's 3189 minimum moves to get a peaceful board. So let's start guys. So given a 2D array rooks of length n where rooks I is equal to xi yi indicates position of a rook on an n by n chessboard. Your task is to move the rooks one cell at a time vertically or horizontally to an adjacent cell such that the board becomes peaceful. A board is peaceful if there is exactly one rook in each row and each column. Return the minimum number of moves required to get a peaceful board. Note that there is no point can there be two rooks in the same cell. Okay. So this is what the problem says. So I hope you are getting the idea. This kind of a, you can imagine as a chessboard and there are a couple of rooks and you want to make sure that there is no rook in the same column, like more than one rook in the same column or in the same row, right? That is where you will get a peaceful board. So this is what the problem statement says. So before we start looking into the details of with some examples and the logic to solve this problem, I would like to quickly say that this channel is to help people in their interview preparation process. If you haven't already subscribed to this channel, please subscribe to this channel now. Your subscription is really important and it's really valuable for us guys. So let's start with the examples. So these are the examples here. So here, okay, so this is the first example, right? So it's a 3 by 3 board here you can see, and these are the positions of the rooks, right? So 0 0 is this one, 1 0 is this one, and 1 1 is this one. Okay, so these are the three rooks here. So now you want to make sure that uh, no rook should be in the same, like more than one rook should be in the same row or same column. So now you will see that these two rooks are in the same row, same column, sorry, same column, right? Okay, so now it means that you have to move this rook here basically, correct? So that one will cause you one movement actually. Also, you have to move this rook here basically, correct? So that there won't be any, I mean, so that board becomes peaceful, right? So for that, to move this rook here, it will cause you two movements, right? Like this or this. This is two movements, or like this and this, like two movements basically, right? So 2 plus 1 is total 3 movements will be required. Okay. So I hope you understood this, right? So you can do, for example, you take this rook and you do one movement here and then here, then it will come here, and you can move this rook after that to this position, right? Then every rook will be in a separate row and separate column basically. This is another example where you have a 4 by 4 chessboard. Now these are the rooks 0 0, 0 1, 0 2 and 0 3. So they are right now in all the same column, right? So now to make sure that they won't be in the same column and same rows, what you can do, you can take this rook and you can move it here. So one movement will be there. Okay, you can take this rook, you can move it here in two movements. So 1 plus 2 is 3, and you can take this rook and move it here basically in three movements. So 3 plus 3 is 6. So that's why the output is 6, right? So I hope you are getting the idea how what they are asking basically, correct? So if you look at this second example, you may think that, it's, I'll just quickly check if they are in the same column. I'll just calculate, easily how much distance I have to move, and then I'll be done. But that's not the case, guys. So here you have to make sure that you have to basically find out their positions by both rows and columns basically, right? Both rows and columns, because they should not be in the same row or same column, correct? So in this case it is okay, but in this case it will not work, right? For example, so what you have to do, for example, so you will need to sort this array actually, this rooks array. So first I will sort this based on the rows. So again I will get 0 0 1 0 1 1 if I sort it by the rows. So so for example 0 is the row here, right? 0 is the row, for example, right? So 0th row. Okay, so it means that I, after sorting also, I'll get like this only the array, and then I will start checking each rook position based on the index. So 0, this is also 0, it means that there is no movement required, right? Then I go to the second rook, I'll get 1 here. I'm looking at 1 basically, correct, on the uh, on the row, right? So it will be correct, and here I'll get 1. I'm looking for 2 based on the index. I'm at 1, so it means that I have to do one movement basically, correct, on the row part, guys. Okay, row part. So you understood row part, right? For example, I'll take this rook and I'll move it here. For example, let's say this is a row, right? So they should be different row. If I place this here, then it will be in different row, right? All three. Okay. So that one is one thing. Now I am not done yet, right? I have to also make sure that they are should not be in the same column also, correct? That is the important thing. Now for that, again I have to sort this array based on the column, right? Based on the column. Again, in this case, the array will look like this only, even if I sort it, right? Then I'll keep checking for the columns. So I will check this value against the index. So this 0 is same as my 0th index. So that is fine. So I don't have to move this rook. Okay, I'll go to the next one. The next one is what? This is 0 and I'm expecting 1, right? I'm expecting column 1. It means that I have to do one movement there, correct? I should do one movement. So I'll take this one here basically. Okay. And this third one is at the first column, so it should be in the second column. For that I will have to do again one more movement, right? So 2 plus 1, total 3 movements I have to do. So the point is that you have to check both rows and columns, right? So it means that you have to sort two times basically, right? And then you can find out your answer. Okay, I hope you understood this clearly. So this is a very the first example is a good example where you can see that you have to do both sortings, then only you can find out correct answer, right? Okay, so I hope you understood this clearly. So basically this rook you will not move at all. This rook you have to take it to here. It means that it will cause you two movements, and this rook you have to take it here. It will cause you one movement. So 2 plus 1 is 3 movements. Okay, and that's why you have to check vertically and horizontally both. Okay, so that is the main idea. So I'll go to the Java code and I'll discuss the code here now. So min moves is the move method we are implementing. A rooks 2D array is given to us. First I am going to sort it on the basis of columns. So A0 B0, right? So you can call it vice versa, it doesn't matter. You call this as a row or column, it doesn't matter. Okay, but first thing you will let's say you are calling it as a column, then you will sort it on the column A0 minus B0. So it's in ascending order, guys, ascending order. So when I sort this rooks array on the columns, this is what I will get. So first this 0, then 0 and then 1, right? So they are in sorted order now. Okay, on the columns. Answer is 0, rooks dot length is n. Now what I will do in this first for loop, I'll keep looping and checking the index versus the position, right? So rooks of I0 is its column position, and I'll check with the ith index, right? If they are same, then 0 movement is required. If they are different, then there will be movements required. I'll take a absolute difference and add it to my answer, right? So this is the first thing I have to do. This one will take n log n time for this sorting, right? So I sorted on the columns and I found out how much movements required for columns actually, right? Now I have to check for rows. So again I will sort the rooks array here. Now the important difference in the sorting is I'm using A1 here, right? A1 minus B1. So I'm going to use rows here, for example, right? For sorting. Again, after sorting also it will look same. In this particular case it is looking same, but it's not always the case, right? So in this particular case, even after sorting they look same, because this is 0, then this is 1 and this is 1, right? Okay, fine. So now again you will do the same thing. You will go through each of the rows, right? Each row, and you will check against the current position, right? So rooks of j of 1 minus j. So you are checking the current position basically, right? The current position of rows. Okay, rows. Okay, and whenever you see a difference, you will need a movement basically. You will add it to the answer, right? At the end, you will have to just return the answer. That one will tell you how many minimum movements will be required so that that board becomes peaceful, right? So now let's quickly understand the time and space complexity. So here the time complexity will be n log n because of the 2 times sorting. So I'll write it down for you guys here so that it will be clear. So time complexity here is 2 times log of n, right? Log of n. n log of n, I'm sorry, n log of n. So now we don't really consider constant, right? So we remove 2. Okay, so that's fine. So n log n is the time complexity because of sorting, and because of no space has been used externally here, right? We are not using any data structure to hold any data, right? We didn't use arrays, linked list, array list, hash set, hash map. So it means that this is going to be order of 1 on the space, or this is also called as constant. So this is a constant on space solution, guys. So okay, so this is the first example that I'm taking, that I shown you here. This is the first example. So we are expecting 3 as the answer. Let's give it a run and make sure that we are getting correct answer. So submit, save this one, run this code. So now 3 is the correct answer. So we are getting correct answer for the first test case. We will try our code on the second test case now. Okay, so second test case, what we are expecting, 6 we are expecting here, right? 6. Okay, so let's give it a shot now and make sure this one again works. So here you are seeing that 6 is the correct answer. So our test cases are getting passed. So this is the correct solution to solve this coding problem. It's on Leetcode 3189 minimum moves to get peaceful board. So another quite interesting matrix related coding problem. So we have solved this problem with the help of sorting, but the main thing you should understand here, that we have to do sorting on both columns and rows, right? Only one will not work basically. Okay, so why only one will not work, I already explained you with this first example, right? If you only do on rows, right, then you will get only one answer. If you only do on columns, then you will get again two answer, which is not right. You have to take care of both things basically, guys. Okay, so that's it for today. I wanted to show you the logic and the approach as well as this Java solution to solve this coding problem, and I hope that you understood this logic approach and this Java solutions clearly. It takes a lot of creativity, time and efforts to come up with these solutions and create these images. So if you really want to appreciate our efforts we are taking here, then try to be generous and give a like for this video, subscribe to our channel, click on the bell notification icon button so you won't miss any interesting upcoming videos from our channel. Share these videos with all your friends, colleagues, so they will also learn how to solve different varieties of interview coding problems. On this channel, we have solved more than 600 different varieties of coding problems. Uh, we have discussed all important coding questions varieties, and we came up with very important playlists for you that you should watch right away. The names of those playlists are graphs, matrices, binary search trees, binary trees, problems solved by using binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices and trees. So everything is here, guys. Lots of data structures problems are also solved, and important data structures playlist we have created for you include stacks, queues, priority queues, min heap, max heap, arrays, array lists, linked lists. So everything is here, guys. Take advantage of these videos, go through them. You will learn a lot by watching these videos. You will learn how to solve different coding interview questions. These are important problems asked by big companies in their interviews, such as Amazon, Apple, Microsoft, Google, Meta, Yahoo, and lots of other companies. So they are very important ones. If you are a Java consultant, we also have created videos to help Java consultants in their telephonic interview rounds. Those videos discuss frequently asked telephonic questions to the Java developers, including core Java, Java J2E, Spring, Hibernate, JP, and other auxiliary technologies. We also have captured lots of MySQL coding problems asked in in-person rounds to Java consultants. So just check out the playlist. You will definitely learn a lot from these videos. And thanks for watching this video. If you like this video and if you like this solution, then please subscribe to our channel and give a like for this video, and have a great day ahead.